All right, so we are doing lesson 5 today, which is graphing and finding values of some functions. The title of the lesson is really like a part 2 of Thursday's lesson. So if you didn't really understand Thursday's lesson, we're kind of covering the same goals as today. So we will continue on. I'm recording right now, just like always, as you've seen. All right, so recording, just like I always do, I think we've gotten the routine down. So when I'm absent, you guys know what you're supposed to turn in. Like regardless of what the sub said, you guys still did turn in, like the majority of you did, turn in your notes. All right, so I do appreciate that. Because if you didn't do the lesson, you're still responsible for it. You're still going to be tested on the same exam stuff. So make sure you get it done. So today's lesson will be attached to the unit 4 lesson 5 puzzle piece. So really all the unit 4, 1 through 5 should be done. And then the next assessment, other than your benchmark, which is tomorrow, but the next assessment will be Wednesday. Because we'll probably finish lesson 5 on Wednesday and then do the quiz after. So reminder, you do have your benchmark tomorrow during this class. I wouldn't stress too much about it. The only reason I even take it for a grade is because if I don't, then kids just guess and then waste an hour of their life. And I don't like wasting time at all. So it will be a grade. As long as you're trying, it shouldn't be a bad grade. And I'll go in more depth tomorrow how I grade it. It's usually a combination of showing work, and then I only grade you for accuracy on the ones that I've taught you so far. So there is going to be some stuff that you may not know. Don't spend the whole test on it, on the same problem. Do as much as you can, and then go back to the ones that you don't know how to do. But if you try, then you should get a good score. If you don't try, then not only will you get a bad score on it, that'll go in the grade book, but they'll put you in like these tutoring groups and make you come to tutoring after so that you can be better prepared for the April one, which is attached to grade books and all those good things. So like take it seriously, make sure you bring a charged Chromebook, charge when you can, bring your charger every day. Get a good night's sleep, eat breakfast, treat it like you would the actual SAT. So how many questions? I don't know, but I know you get like 40 minutes to do it. So I want to say approximately 40 questions. Since normal SAT, ACT is 1 minute per question. But I didn't look at it. The district made it, so I just give it to you and then I look at it. So any questions? All right, so that's her. All right. Now on to the warm-up. So for number 1, what value of Q would make the equation true when P is 7? What is it telling you to do? How do I solve 1A? Put 7 in for the P. So copy the equation if you need to. And it's asking you what is Q when P is 7. So Q is what you'll be solving for. Anytime you plug stuff in, what do I tell you to use? Good. That way, if it implies multiplication, that you make sure that it actually does. So it would look something like that when you plug it in. This one is nice because you could type in this whole right side into your calculator all at once. Unless you're using like your phone calculator, then you really have to know your order of operations. So what would you do first normally? Add or multiply? Multiply and then add the 4. But again, if you don't even need to invest in like a lot of money if you can't right now. You can buy like those $13 calculators I showed you. But any calculator where you can type in multiple things at once are a good investment. So 4 plus 0.8 times 7. You should have gotten 9%. If you got anything else and you use the calculator, let me know because odds are You're probably typing something in wrong. It might be that you're not using your correct order of operation. So there you go. Q for 1A is 9.6. Questions there? What about when P is 100? All right. That is correct, 84. So again, all you're changing is the P. When it's in this form, it's really nice. You can just put it in your calculator and let it do the work for you. Now, how is number 2 different? Good, so now we're plugging into the Q, which also like gives you some different work that you have to do. So for 2A, here's where the work will be. 12 is going into the Q spot, so right here. Equals 4 plus 0.8 times P. Now, is that as easy to type in the calculator all at once? No, so you'll have to isolate the variable. So what would I get rid of first? And this is where like the solving for a certain variable, this is where a lot of people struggled on the test. So if that's been a struggle for you, like pay attention. Anytime you're isolating a variable, I always tell you to start with what is farthest from that variable. So what's farther, the 4 or the 0.8? How do you make that 4 0? Whatever you do on one side of the equal sign. What's 12 minus 4? Good, so then this cancels. I have just 0.8p. How do you get it fully by itself? Divide 0.8. Whatever you do on one side of the symbol. And what does p equal? 10. All right, good. What about when Q is 60? So don't call it out right now because I have a feeling a lot of you are doing this for the first time. So using this as a model, solve for when Q is 60. I'll give you like 30-ish seconds. Don't call it out yet. You guys are correct. If you didn't get that, same steps as before. Start with what's farther from the P. Whatever you do on one side of the equal sign, you do to the other side. Inverse operations, that means doing the opposite of what's being done. So instead of multiplying, we divide. And yes, when you put that in your calculator, P is 70. All right, now it seems kind of weird that we're doing a problem like this when that's more like a unit 2 skill. And what have we really been focusing on lately? Not necessarily. Not necessarily that either. Other than that, so look at the title. Using function notation to describe rules. Is this in function notation? All right, it's not in function notation. Anyone know how I could make it into function notation? What does function notation look like? F of, okay, so instead of having it where it's normally like x, y, function notation is now f and f of x. So like input and output. And this one, what is most likely my input, the P or the Q? The P. What is most likely my output? The Q. So your output is usually what's dependent on your input, right? So like when we do stuff to the input, that's how we get the output. If I wanted to make this function notation, let's say function f, what would be in parentheses? No. Function notation, f of x. But in this one, it would be f of, not Q, P. What's in the parentheses is always your input, right? So this one is f of p, p is my input, and then the rest would be exactly. All right, now, if I had it in function notation, usually they always give you the given equation. So some people ask, like, how do you know what to plug it into? It's usually always in your instructions, just so you know. But having things in function notation kind of eliminates the need for me to write all this stuff. Like, what is the value of Q that would make the equation true when this and this? All right, instead I could just write f of 7, f of 100. And that's telling you to find the value of the output when the input is 7 and when the input is 100. Does that make sense? Because people still give me blank stares when I tell them to find, I don't know, for example, a of 1. And that's all it's asking you to do. And this one is asking you to find what though now? The Q, which is not your input, right? So then it would be something like this, if it was in function notation. F of P equals 12, and then you're solving for the P. Or in the second one, f of p equals 60, and then you're solving for the p. All of that would eliminate all these words. And that's all we're trying to get you to recognize, is that function notation is telling you to do that, what we just did in the warm-up. So questions on that? All right, so now on to something that is actually printed on your paper. So let's talk about phone data plans. I don't know about you, but I don't think your parents are going to let you stay on their plan forever. So this is something that you might actually have to consider. My parents always let me stay on their plan, but then once I found out that it's cheaper to be on my boyfriend's plan, I just switched over to that. So really something that you might actually have to consider. So a college student is choosing between 2 data plans for her new cell phone. Both plans include an allowance of 2 GB of data per month. The monthly cost of each option can be seen as a function and represented with an equation. In each function, the input X represents the gigabytes of data used over the monthly allowance. So again, class, what does the input represent? Good. It says it right here. So anything that's in the parentheses is going to be gigabytes of data used over the monthly allowance. All right, so in addition to the monthly allowance. And then what must the output mean? So like, what must the 60 mean in option A? No, I heard someone say it, but I want more people to think about it. She's figuring out which data plan she might want to use. So the output would be her, yeah, the cost. The cost when she goes over. All right, so then same for this one. X is the gigabytes of data she used. This expression right here would represent her cost. If you ever have trouble with that and then they provide a graph, that makes it super easy. Because your input is usually on what axis? The x-axis, which it is, data used over allowance in gigabytes. And then look at what's on the y-axis. Cost, that's what we said the output represents. So just remember that. I have it pasted on the next page, so we're going to go to the top part. All right. So the student decides to find the values of A of 1 and B of 1 and compare them. What are those values? So what does A of 1 mean? What does A of 1 tell you to do? All right, function notation. All I want you to do is tell me what A of 1 is telling me to do. Think of the warm up. So is it A times 1? No, here's the functions again. Here's option A and option B. If I'm telling you to find A of 1, what am I telling you to do? Kind of, so, what am I telling you to do with the 1? Good, so since it took you guys a while to get there, circle this on your paper and write what I'm ready. So what this is telling you to do is plug 1 into function A. All right, A of 1 is just telling you to plug 1 into function A. And here is function A, so plug it in. Anywhere that there's an X, you put a 1. And do I need to do any simplifying on the right side? Yes, no? No, because it's already, there's nothing else I could do. It's not any other operation. So then A of 1 equals 60. Now find B of 1. So what is B of 1 telling me to do? Good, what are we plugging in? But what number are we plugging in? 1. Okay, so then plug 1 into function B and figure out what the output is.
Miss Medina. Bellin, yes. Yes, no problem. Bellin, you're needed in 11:18.
Yeah, you need me to write it down. B of 1 is shorthand for saying plug 1 into function B. So here's what it should look like plugged into function B. Or actually, let me ask you, what would it look like plugged in? Well, anywhere that there's an X, we're supposed to replace with what? All right, everyone sit up. Pay attention, this is painful. This is painful for me. To me, this is like so easy. I don't know why it's not easy to you guys either. But also like if you're not paying attention, Michael, sit up. All right, we're never gonna get through this if you're not participating and paying attention. So sit up. I already told you. B of 1 is plugging 8 into where? Or not 8, 1 into where? Into the X in what function? The B function. So what does it look like plugged in? So far we have B of 1 equals 10 and then what? All right, times 1 plus 25. Anyone confused on where we're getting these numbers from? No. All right, literally right here. Function notation, like 99% of the time, it's already given to you in the direction. You just have to be able to understand, this is telling me to plug 1 into function B. So then you plug it in. Can I simplify the right side? Yeah, 90% of the time, you do have to simplify the right side, but it's usually something super easy like this that you can put it all in the calculator at once. Or just know your order of operation. What's 10 times 1? And then plus 25? That's that easy. And then compare the values. So which plan is the better option? When it's 1 for the input. B, it's cheaper. All right, questions on part 1? All right, now do number 2. After looking at some of her past phone bills, she decided to compare A of 7.5 and B of 7.5. What are those values? So what am I telling you to do? With that 7.5? Michael P? Plug it into X in what function? Good, A, and then B of 7.5 is telling you to plug it in to the B function. So do that, everyone should be able to tell me that answer, because you all have access to the calculator. If you can't, then tell me what you're confused about. But like, we need to participate, because we're falling behind. All right, so I'm about to ask, and honestly, everyone should be able to answer, everyone. Like the answer should be so loud that like the teacher next door can hear it. So what is A of 7.5? All right, what is B of 7.5? All right, good. That's perfectly right. And plugging it into the A function, why did we get the same output as when we plugged in 1? Because the right side is unchanged. On the right side, it's just 60. So no matter what the X is for function A, what's my answer output always going to be? 60. Good. Why is it different for the B function? Good. When you plug in that 7.5, it looks something like this on the right side. Do your order of operations or put it on your calculator. 10 times 7.5 is 75, and then plus 25 is how we get the 100. So now which one is cheaper? A. And I guess it just depends on how often she plans to go over her allowed amount. Now we're going to graph each function, which we were able to do in my other classes, so this one fell behind. So let's do as much as we can right now, so that we're kind of aligned. For function A, what coordinates do we know for sure are on the graph based on what we've done so far? I don't need it. Yeah. Give me the value. 7.5 and 60. So that's a great test question. Just so you know. And I made the quiz that's coming up, so I know what's a great test question or not. So anytime it's paired like this, input and output, you can write it as a coordinate. What's another point that we know for sure is on option A? One and 60. What about for option B? What points do we know are there for option B? 1 and 35, and then what's the other one? All right, good. Tomorrow we'll go over how to find other points to put on here. But yeah, then we're gonna graph it and finish the lesson on Wednesday, since tomorrow is your benchmark.